quotient rule. I don't know why. I don't know if my teacher encouraged that or if I just liked it better. I'm not sure. A lot of times I tend to I don't really like memorizing things, so I work my way around memorizing things sometimes. So maybe that was just me doing crazy stuff. But so we're going to use quotient rule on this, but on the next one I'm going to use product rule, and I'll show you how we can do that. So we got x over, I'm going to write this as x squared plus 4 to the 1/3 power. Alright, so if we were going to take the derivative of this, we must use the quotient rule. So low d high minus high d low, all over low squared. So we'll have x squared plus 4 to the 1/3 times the derivative of the top, which is just 1, minus x squared plus 4, I'm sorry, I don't like doing high, which is x, times the derivative of the low. Now right here you have to use the chain rule. Okay, so we're going to have 1/3 x squared plus 4 to the negative 2/3 times the derivative of the inside, which is 2x, all over x squared plus 4 to the 1/3 raised to the 2nd power. Now technically at this point you have taken the derivative. If it is a free response problem, you could quit. Although most of the time they're going to ask you to do something else with this, which means it would probably help you to simplify it. But if you see this multiple choice, they're definitely not leaving the answer like this. So the first step, most students do pretty well with that. If they do forget anything, it's say forget this 2x right here whenever they're doing that derivative of the bottom. But most students are okay here. The simplifying is what becomes difficult for this. So next step, I'm going to clean this up a little bit. So I've got x squared plus 4 to the 1/3 power minus, and here I've got 2x, 1/3, and x, so that's going to be 2/3 x squared times x squared plus 4 to the negative 2/3 over, this can just be written x squared plus 4 to the 2/3 power. So, we should be seeing here these pieces right here that match, but they have different exponents, right? So, there's a few different ways that you can deal with that, but the way that I usually use is that I factor out a greatest common factor. We did this a little bit, but we had whole number with product rule, but we had whole number exponents, right? So if we had like x squared plus 4 to the 5th and x squared plus 4 to the 4th, we would take out an x squared plus 4 to the 4th, right? You want to do the same thing here. You are factoring out the lowest exponent out of the numerator, okay? So the lowest exponent is going to be your negative exponent. So we will be factoring out an x squared plus 4 to the negative 2/3 power. Now, it's a little difficult to think about what you're doing there. Whenever you're factoring something out, it's like you're dividing each term by that value. So you got x squared plus 4 to the negative 2/3 and x squared plus 4 to the negative 2/3. You're not messing with the denominator here. You're just factoring out a greatest common factor out of the numerator. So over here it's not too bad because these two just cancel. They're the same. But over here, if I think about what is happening over here, my little thought bubble of what is happening, I've got x squared plus 4 to the 1/3 over x squared plus 4 to the negative 2/3. What do you do with those negative exponents? Move them up to the top. That means you'll have x squared plus 4 to the 1/3 times x squared plus 4 to the 2/3. What's that going to give you? X squared plus 4 to the first power, right? Because the 1/3 plus 2/3, we're multiplying there. It's just going to be x squared plus 4. This is going to happen every time, where this is going to be like a whole number exponent whenever you do this. So that means what all this thinking over here was just to explain why x squared plus 4 to the 1/3, when we pull out a negative 2/3, it is going to leave us with x squared plus 4. And then over here, in that second term, we factored out the x squared plus 4 to the negative 2/3, and so that just leaves us with the 2/3 x squared. Give you a second to think about that, make sure you understand what's happening. Okay, so now if we could not send this down to the bottom at the beginning, because if we did, it would have to be just the bottom of this fraction, because we had that minus sign in between, which you could do. You could make it like fraction, common denominator sort of stuff. You could do it that way also. But you can't just take this with its negative exponent and send it straight down to the bottom, because it's going to mess up, because you didn't take it out of this part as well. But now that we have factored this out, it is multiplied by the stuff we have in the bracket, so we can take this and move it down to the bottom. Okay, and then we can simplify what we have here. So we have x squared minus 2/3 x squared, which is going to give us 1/3 x squared plus 4 in the top. We got x squared plus 4 to the positive 2/3, and then we already had x squared plus 4 to the positive 2/3. That is going to give us 1/3 x squared plus 4 over, what do we get when we put those two together? X squared plus 4, what power? 4/3. We're going to just add those together. 2/3 and 2/3 will give us 4/3. And they're probably still not going to leave it like this, because you still have that 1/3, which is a fraction in the top, and they don't like to leave fractions inside of fractions. So to get rid of that fraction, we could multiply the numerator by 3 as long as we also multiply the denominator by 3. All right? So if we do that, we will get just an x squared, because 1/3 times 3 is going to give us 1, and then 3 times 4 will give me 12, and then in the denominator we'll have 3 times x squared plus 4 to the 4/3. And this is what you are most likely to see on a multiple choice question. We are going to have a quiz on this, I think, Thursday, and it will be multiple choice. So We need to be good at simplifying those down. Okay, questions?
At this time, any 10th or 11th grader who needs picture retakes or did not get yearbook picture dates, including new students, please report to the media center at this time. Thank you.
Alright. Questions? Alright. I want to do this next one without using the quotient rule. And you guys can decide which one you like better. I almost think I might like it without the quotient rule better. But either works fine, and you are welcome to decide for yourself. So, if I do not want to use the quotient rule, how could I write this so that the quotient rule would not be necessary? Because right now I've got a fraction, which means I've got to use quotient rule. Two x times what? You would still have to use quotient. Well, let me write the way you just told me, like this, 1 over root x squared minus 4. Okay, so you would still have to use quotient rule on that second part. You'd use product rule, but you have a quotient rule right here. Perfect. So if I write this as 2x times x squared minus 4 to the negative 1/2, then now I do not have to use quotient rule. I do have to use product rule. If you don't use product rule, you get it terribly wrong. But I could use product rule instead of quotient rule. So, again, quotient rule works fine. We could do this basically like we did the last problem. But if we're going to do it this way, then I'm going to call this g of x. And I'm going to call this part right here h of x. I'm just avoiding using f of x because they called this function f of x. So it would kind of be wrong to call one of the pieces f of x. You don't have to write this at all. I'm just doing that to try to clarify. So our product rule, there, I'm going to write it down. You don't have to. I'm just reminding you that it's g of x times h prime of x plus h of x times g prime of x. Alright, so our derivative here is going to be g of x, which is just our 2x, times the derivative of h of x. So we got to use chain rule for that. We'll have negative 1/2 times x squared minus 4 to what power? Negative 3/2. We're subtracting 1 from the exponent, but what do we have to multiply that by? 2x, the derivative of the inside, which is x squared minus 4. Plus, we have to have h of x, which is x squared minus 4 to the negative 1/2, times g prime of x, which is just 2. Okay, so I'm gonna label these so we all know where everything's coming from. This is g of x. This is g prime of x. And then all of this stuff right here, that's your h prime of x. That's where we had to use that chain rule. And then this was just h of x. Okay, questions? Right here, technically, you're done. You've taken the derivative, but it's unlikely that you're going to be able to leave it like this in most cases. So we want to clean it up a little bit first. I've got 2x, negative 1/2, and another 2x. So that is going to give me 2x squared times x squared minus 4 to the negative 3/2. And then over here I'll have plus 2 times x squared minus 4 to the negative 1/2. Yes, thank you. I lost that negative there. We're okay here? I think it's easier without the quotient rule. It's just a little easier. You don't have to worry about keeping up with that denominator. So we've got a similar situation as we had last time. We've got these two factors right here that match, and we can factor that out as the greatest common factor. You want to take the lowest exponent, which in this case is the negative 3/2. That's what you want to factor out. So I'm going to try to factor out a x squared minus 4 to the negative 3/2. Which means what I'm doing is I'm dividing this term by x squared minus 4 to the negative 3/2 and this term by x squared minus 4 to the negative 3/2. All right, over here it's pretty simple. What happens, that x squared minus 4 to the negative 3/2 is just being taken out. They cancel. You've got negative 2x squared left from that first term. The second term, you definitely don't have to write this, but I'm going to do a little thinking bubble here about what's actually happening so we can think about it. What happens here is I've got 2 times x squared minus 4 to the negative 1/2, and then if I move this up to the top, I've got x squared minus 4 to the positive 3/2. All right, if I move that denominator up to the top, what would I do with those exponents? Add them together, negative 1/2 plus 3/2, 1. So this is just going to be 2 times x squared minus 4 to the first power. So here, that will go here. Is it all right with you guys if I go ahead and distribute that? 2x squared minus 8. Right here. Okay, so now I've got x squared minus 4 to the negative 3/2 times these two actually cancel. I'm just multiplying this by negative 8. They do not usually leave negative exponents, so they will probably rewrite this as x squared minus 4 to the negative 8 over x squared minus 4 to the 3/2. Or they might even change it back to a root there. I think it's a little easier. Do you guys think it's a little easier without the denominator there? You do have to deal with those negative exponents, but you really had to do that on the last one anyway. Okay, questions? All right. Let's see. Do I want to do that one? I'm going to skip that one. I'll skip to 4 here. All right, so for this one, we have y equals 3x minus 1 over x squared plus 3, and all of that is squared. So this is a little bit like the one we did for the warm-up, but we don't have a natural log. Our outside function is that this stuff is being raised to the second power. Our inside function is our 3x minus 1 over x squared plus 3. So the inside part is where we're going to have to use quotient rule. The outside, we do not. So when we take the derivative of this, the outside is just going to be 2 times, leave the inside stuff the same, 3x minus 1 over x squared plus 3 to the first power, if you want to write it, but you don't have to write that, obviously. Now we need to multiply by the derivative of the inside. Here is where we have to use quotient rule. So we could do x squared plus 3 times the derivative of 3x minus 1, which is 3, minus high 3x minus 1 times the derivative of the low, which is 2x, all over x squared plus 3 squared here. I'm just going to leave that stuff out there for right now. We could distribute. So we got 3x squared plus 9. And then we'll distribute here. Don't forget that negative, so we'll get minus 6x squared plus 2x over x squared plus 3 squared. And that would be negative 3x squared plus 2x plus 9. And then they will probably write this like all together. So it would look like this: 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 over, and this would be x squared plus 3 cubed. And I don't think negative 3x squared plus 2x plus 9 is going to factor into anything that would cancel. I know it won't cancel with an x squared plus 3 in the bottom, so there's no like advantage to factoring that. So just leave it like this. Okay. Questions here? Second, look at it. Any questions? All right, I'm going to change the assignment a little bit. I want you guys to do 27 and 28, and then 29, 31, and 33. So you got about 15 minutes to go ahead and get started on that right now. Let me just go ahead and tell you the answer in the back of the book for 28, because being able to simplify these down is really important. So for 28, you should get 4 minus x to the 4th over the square root of x to the 4th plus 4 to the 3rd power. And then the rest of them are odd, so you can check the back of the book for those. And 27, 28, you can use quotient rule if you would like, but you also could use chain rule. If you just take that denominator, move it up to the top with a negative exponent. So whichever one you prefer there is fine. Change this